recording. Lovely. All right. So, see it a bit better and also give you mood lighting so people at the front fall asleep. Welcome to week 5. You've survived 5 weeks of this. Congratulations. I say experience. Next week is reading week, which you should probably do some reading during. But let's get into this. Week 5, we're going to talk a lot about dimensions this week. Last week, we talked about fillets and chamfers. Quick review, why might we include a fillet and or a chamfer in a design? Yes? So you don't cut yourself. Sharp edges are sharp, blunt edges are less sharp. Yes? In certain circumstances, it can reduce the manufacturing cost. Absolutely. Others? Yes. Right? There's sharp internal corners can cause stress concentrations. A fillet can distribute that stress. Makes it actually possible to make it. That is, let's go with mostly true. To easily make it, yes, it can make things much easier. Usually it's possible to make things with square corners, but you might have to spend a lot of time with a tiny file. Yeah, it's pretty. Sometimes making things pretty is good enough. All right, tool of the week last week. Anybody remember our tool of the week? Yes. It was a sewing machine, absolutely, which I like to remind all of you that exists because we spend a lot of time talking about tools we use on steel and aluminum, forgetting entirely that there are other industries and we use different tools for cloth and cardboard and plastic than we would to machine metal. All right. We also did a bunch of CAD, whole bunch of CAD, and at this point, you should be able to make any shape that you want. You have the tools to do that. So from here on out, we're going to talk about some more nuances of either using CAD better or dimensions. There'll be a lot of dimensions today. Like I said, today, there'll be a lot of dimensions. So let's start with a couple nuances of AutoCAD. We've dealt with this a little bit in the past. Let me just start up a new drawing, and let's make a circle that is, yes, I know you can't see what I'm doing. There we go. So here's a circle. Home, thank you. And let's put in a little rectangle here that is 10 by 20. Oh, I must have typed wrong, but doesn't matter. Here's a little rectangle and a little circle. Isn't that nice? I'm going to throw a dimension on this circle, just so we get an idea and we remember how big these are, and one on there. So we've talked previously that in model space, everything here is unitless. This is size 20. 20 what's? I don't know, but it's 20. It's definitely 20 somethings. However, when we print this, I'm in the middle of a command. When we print it, sometimes we want the size on the page to mean something. So if I put a ruler against it, I would be able to print this out and go, hey, this is exactly the same size as it should be in real life, or it's twice as big, it's half as big. That's a thing that we need to worry about over here. So what is paper space? Paper space in AutoCAD is a way of separating the world of our model, where we draw everything one-to-one in an empty, gigantic, endless void, and the world where we put some parts of that model, maybe not all of it, onto a piece of paper and print that out. So paper space is where we set up those pieces of paper. This white thing is our piece of paper. This thing in the middle is what's called a viewport. And this is a window into our model space. And we can adjust the size and shape of this viewport and location, just like we would any object in our model space. We can also jump into that window, either by double-clicking inside it. Hey, look, it's just like I'm in model space again. Or down here where it says paper, if I click on paper, it flips over to model space. And then I could work in here like it's my model. I'm going to, for example, turn off the grid lines. Center this a little bit better. Now this is a little bit weird to get used to, but it's incredibly useful because I can now treat my model just as the shapes and sizes of things I want, and my paper as what I want to print. That means things like title blocks don't have to show up in my model. Because I don't want my title block like here where I'm drawing. That doesn't make any sense. Why does this drawing care what my name is? Only the paper cares what my name is. And so I can make a title block. Let's make a really quick title block. Here we go. So this is a quick and bad title block. And text. Name. Ryan. And another title box, or another text box. Drawing. Very good shapes. So, this isn't a good title block, but I can make this title block, and then it exists on this piece of paper. But it doesn't exist in this model, so it's not going to get in the way of my drawing. I don't have to worry about getting the text right, size right in this drawing so it looks right on this page. I just make it look right on this page. We can also have multiple viewports if we so desire. So if I want a detail of this circle, I could just have this viewport be like, hey, let's have a look at this circle. And I can also go into my Layout tab and create a new viewport. Layout viewports, got a bunch of options here. I'm just going to throw in a rectangular viewport. Wow, there it is. And I'm going to make this one just be a detail of my rectangle. So this is useful if we have a very large drawing with many details and I want to zoom in on different portions of it. Maybe have many pages, one with the whole thing and then another page with just some details. I can have multiple viewports looking at different parts of those drawings. And on all of them, I can put in a title block quickly and easily without having to have repeated title blocks on my drawing. We can also, as you might expect on in paper, control what kind of paper we're going to use. So if I go down to Layout and I right-click, I'm going to get Page Setup Manager. I think if we type Page Setup, we also get the same thing. And here we get a list of our layouts that we've worked on, and we can create new layouts, so you can get new layouts. And I am going to modify this one so we can have a look at all the details. We can pick our printer. So if, for example, I am exporting a high-quality PDF, I go, oh, AutoCAD PDF, cool. What paper sizes? Here, oh, look at all the paper sizes I can use. But this list will get limited based on the printer you pick. A common size to print to for many drawings is 11 by 17. You'll see we have two. One is in portrait, one is in landscape. I can decide if it's portrait and landscape. I can decide if I print line weights. I can turn on and off various items to print. And you go, oh, hey, look, it's resized. I can move things around on my paper using my old AutoCAD commands, resize my viewports, etc. Let's only have one viewport on here for the moment. Let's make it take up, because this is mostly what we do. One viewport taking up most of the page except for wherever our title block and other things might show up. And then I'm going to go, well, I want to show as much of this drawing as possible, so there we go. There's a good zoom. Great, cool, but when I print out this page, what scale will this be at? This is where AutoCAD finally cares what units you're using. In my layout, one of the options in my Page Setup Manager was explaining what my AutoCAD units meant. So if I'm working in inches or millimeters, I can explain that and say, well, this right now is converting 25.4, let's flip to millimeters. This is saying 1 millimeter is equal to 1 inch. That's what I drew it. This is where I explain that. So if I do that and I go, okay, 1 millimeter was 1 unit in my AutoCAD drawing, close that up. Now if I go into my viewport, it can figure out very quickly my scale relative to my page. Oh, when I print this off, this will be 4.7596 times the actual size. This is where we now have to use some judgment. Is for this little number in the bottom corner, scale of the selected viewport, is 4.7596 a particularly good scale? No. Nobody wants to have to punch that into a calculator every time they transfer a measurement. And so I can go, well, how about a 4 to 1? There we go. Now it's 4 to 1. So I get to have a drop-down menu. And I can set custom ones, but this is just a list of standard ones of different scales. Here's 8 to 1. Oh, that's too big, doesn't fit inside. 2 to 1. Oh, way too small. 4 to 1, that's pretty good. Maybe I can fit 5 to 1. Let's throw in a custom scale. Add. 1 paper. So, okay. Oh, 5 to 1. So now that should be in my list. 5 to 1. Oh, hey, that's pretty good. That is dumb luck that fit nicely on that page. So that lets us scale our drawings to our page, which is why we don't care what we draw in here, because it doesn't matter until we print them out what the relative scale is. And depending on how many different pages I have, different pages might have different relationships and different scales. So there is our quick rundown of Paperspace, which means from here on out, you guys should know how to set up a drawing on a piece of paper. You should be able to pick your paper size. You should be able to put a title block in Paperspace, and you should be able to scale your viewports appropriately, which you may guess means from now on you have to. Yes? Oh, you have to, oh, excellent question. There is no default that is going to, there probably is. Now that you're saying that, there's no easy, straightforward command for it to automatically display your scale on your page. You typically type that in manually into your title block. Same with the units. You'd say, you know, drawn in like all units in millimeters, scale 5 to 1. There are fancy ways that you can couple text to parameters, but way outside our scope. We're going to do SolidWorks instead. Yes? Oh, so if I wanted to say, make this, the viewport take up basically the whole thing, and then have my title block down there. Absolutely. So the question is, how do I do the dimensions from the outside of the paper? So you can use all of your AutoCAD commands in here. So you could draw lines and set spaces on there. These dotted lines are the print area of whatever you selected. So if you tried to print this off, anything outside those dashed lines would not appear. I just eyeballed this, but you can absolutely go, oh, I want this exactly 1/8 of an inch in or 1/4 of an inch in from the edge of the paper. I go, hey, line, let's go. Oh, it's not snapping to those. I thought it did snap to that. Anyway, you can just draw it in. Generally, we don't care about exact dimensions from outside the drawing. We care about inside the drawing, what sizes things are. So you can eyeball those. That's fine. If you want to, you can set up lines and measure things. Yeah. Well, so these represent whatever I drafted in. And what I have explained in my page layout here is I'm explaining to this piece of paper what units I drafted in. So it's saying that one unit of my drawing is 1 millimeter. And so that then it can figure out what the scale is. But yeah, the 20 is just whatever unit I drafted in. And this is one of the reasons we always draft in 1:1. You just, whatever units you use, you draft in that unit, those units, and then you can scale it as much as you want in your paper space. All right. On to line types and line weights. So we have already been doing this. Oh, come on, open up. Be my friend. There we go. We've already been doing this sort of casually in the background, but now I wanted to formalize it. In drafting, we have some standards for how lines should appear. We've talked about object lines, which are solid, hidden lines, which are dashed, center lines, which are long, short, short, long, short, short, long, long, short, long, short, long, short, long. They also have associated line weights. Our object lines should be thick. Nice, easy, clear to see, thick lines. Our hidden lines should be sort of a medium weight, and our center lines and dimension lines should be thin. This helps us visually distinguish between them. So I am never going to mistake this object line, which is thick and heavy, for this dimension extension line, which is quite thin. Also on here, we have phantom lines, which we haven't talked about before. They don't come up much. But phantom lines we use to often describe alternate positions of an object. So here you can see this handle moves from horizontal to vertical. It can swing through that range of motion. And we have this phantom line describing its alternate position. And that is a long, short, short, long, short, short. So it looks a little bit like a center line, but we've got 2 shorts instead of 1 short. Those phantom lines are very thin. Yeah. What are section lines? What a wonderful question. Thank you for the lead into the next topic. So this AA, this is a section line. And we're going to cover sectioning later in more detail, like how to do it well. But a section is if I want to cut into an object, cut through it, so that I can see like a cross section of it. A section line is what describes that cutting plane. So a quick rundown, AA is saying that somewhere else on this page, I'm going to have something that says section AA. I'm going from A to A. And what that will be a picture of is if I sent a saw down through this plane and cut this clamp in half, what would I see if I looked in the direction of these arrows? And what I would see is section AA down here. So this is a cross section of this cutting plane. The other one we haven't really seen much of is a break line. So this clamp, according to this dimension, is 1 meter long. But between the bottom of this clamp and this hole down here, nothing interesting happens. It's just a big long bar. And so what we've done is break that bar and chop off the big middle of it just in our picture. So we don't need to show the whole big long bar where the only thing interesting happening is up here. We've taken all of this boring part and shrunk it down. You've probably seen the same thing happen on graphs at certain points when you're like, well, if we actually graphed this whole thing, there'd be 1,000 points of nothing and then some interesting stuff happening way off here. So we truncate the boring bit. We can do the same thing in AutoCAD. And this is an example of a break line. There's a couple different styles. And the break lines should be the same as the object being broken. Quick rundown of what we mean by thin, medium, and thick. This is a little bit unintuitively the size of pen you are using. So when you draw at 0.6, that's not 0.6 relative to your page. That is a 0.6 millimeter thick pen, which means no matter our zoom level, it's always going to be 0.6 millimeters. Because it's imagining that you have redrawn, every time you zoom, it's imagining that you've redrawn your entire picture using the same set of pens. The line weights do not scale by default. So our medium line weight is at about 0.3. Our thicks that are about 0.6 millimeters. Our thins are quite thin, 0.05. So these, if you went and bought art pens, that's how thick those art pens would be with your inch equivalents. Yeah. Very thick, probably around 1. Have I talked about a line scale with you guys, scaling your lines up and down? So, problem with me teaching multiple classes, I get mixed up as to what I've told who. So let's talk a bit about line scale briefly. So we've got line weight and type in here. So let's, first off, I've told you how to load line types, right? Good. So let's load on my own screen. Thank you. Let me load in. Oh, that also showed up on the other screen. Wonderful, thank you. Let's load in just a hidden line, not dashed, hidden. Okay. Oh, and what you guys will get when you see it is this. And then if I draw my hidden line, let's go, hey, hidden line. There's a hidden line, and you can clearly see the dashes. But depending on my zoom level, those dashes might be very hard to see, or they might be they might be too big. I gotta be like, oh, if this is the scale I'm drawing to, if like this is the object I want a hidden line in, that hidden line is way too big, right? It just looks like a solid line. So in our line loader, show details, we have a couple critical things we want to play with. First off, global scale factor. This will adjust the scale of all of my lines. So I could, if I want to shrink my line, say 0.1. Now that will be 1/10 the size that they are currently appearing. The other one that I want you all to pay attention to, because this probably messed up many of you in a previous drawing, Use paper space units for scaling. Turn that off. What this does is readjust your lines for paper space based on the paper space units you set up, and it won't look the same as your model. Now, this is very useful if you know how to use it correctly, but until you get used to using it correctly, it's a giant pain. And you'll make your model look perfect and beautiful, and then you'll go to paper space, and it will look weird. That's what this guy's telling you to do. We can also change our thicknesses. So here's we've got our thicknesses. Like do. So again, we've got 0.3 and for our thicknesses, and you'll notice the first thing that happened was nothing. We absolutely changed the thickness of this. If I pick this again, it says, oh yeah, that's 0.3. But why didn't it change its appearance? If I type in line weight, you'll see that by default, display line weight is turned off. So I turn that on. Now I can see my line weights. You'll also notice that as I scale in and out, it stays the same thickness on the screen. So here it sort of looks thinner, and here it looks thicker, but it's actually just staying the same number of pixels wide. It's the line weight is the pen thickness, not an absolute thickness. Yes, at the back. Will the line type scale affect center marks and center lines? Absolutely it will. So if I go and annotate and go, hey, let's throw down a center line between here and here, you'll notice it's quite fine. If I change that global scale back, it would be back to normal. Again, we went to our line type loader. We need details shown, and if I change this global scale factor back to 1, all of my line types should adjust. Yeah, it's fine.
Is there a way to like set the line weights to make default so each time you make a new drawing you don't need to set it for each individual line type?
Oh, you guys are so good. Is there a way to set a default so every single thing I draw I don't have to change the line type? Absolutely, that is the next thing we're going to do. So do activity 1, line weight and line type. You've got about 4 minutes to do it. You guys should be able to crush through it. And then we will talk about layers. Oh, just a couple things that have come into my head while you're working away. One, don't forget to get into your robot groups. I have wonderful and terrible news because you have to be in groups of 4, correct? So if you have formed a group of 3, tomorrow morning we will dissolve that group of 3 and you will have to find a group of 4. If you're not in any groups, we'll form the last of people into groups. But get yourself into groups of 4 so that you actually get to pick your partners rather than us thrusting you upon each other rudely. The other one, sadly, no lunch tomorrow. I know. turns out, feeding all of you is expensive. So we can only do it so many times. And also, a bunch, the morning crew will be, probably many of them will be finished. And so making them wait around for like an extra hour to get a lunch is rude. So No lunch tomorrow. Apologies. I'm also sad. I wanted free lunch. All right. Let's get into the exciting world of layers. So, we have already decided that it is annoying to draw things and constantly go, I would like to make a line, and then I'm going to change its line type and its line weight, and then I'll make another line and change its line type and line weight. And then, oh, now I want to draw a hidden line. Let me also change its line weight. But you'll notice in all of these properties, in my color, in my line type, or in my line weight, and uh, in my line type, there's this by layer option. What does that mean? Well, let's look over a little bit to the left, to the layers menu. If anybody's worked in Photoshop or Illustrator or anything like that, you'll be familiar with layers. AutoCAD also has layers. What layers allow you to do is assign a bunch of properties and group certain kinds of things together. So here, whenever you start up a drawing, you end up with basically two layers, layer 0 and def points. Ignore def points. That's just a thing that AutoCAD needs to do. But in layers, if I open layer properties, I can create new layers. So you see this little stack of paper. Every time you see a stack of paper, those are your layers. With the little star beside it, that's a new layer. So I'm going to make a layer called hidden. And what do I want my hidden line layer to be? Well, I do want it to be white. My line type, I don't want it to be continuous. I want it to be hidden. What's my line weight? Well, for my hidden lines, I want it to be 0.15 millimeters. Let's make a layer for object. What do I want those? I want that layer to be continuous, and I want the thickness to be 0.3. Let's make another layer, and this one's useful. Dimension. Again, continuous, and I want that to be nice and thin. Just for illustrative purposes, I'm going to make them different colors as well. I'm going to make my object bright blue. I'm going to make my hidden lines fuchsia, and I'll leave my dimension lines as white, just so you can see the things we can do with layers, and they're a bit brighter. So now, rather than playing ever with these properties, now that you know how to play with these properties, stop doing it. Never do it again. Hi, at the back. No, hidden lines were 0.15, right? Oh, you mean in these instructions? Oh, yeah, these instructions are, oh, you're right, it's point oh 0.03. Whoops, I'm breaking my own instructions. So yeah, let's make our hidden lines 0.3, and these ones 0.6. Um, Dear Ryan, follow your own instructions. So let's, rather than ever messing with these ever again, pick our layer. Oh, I'm drawing my object. Let's draw on my object layer. I'm gonna draw a box. Oh, look, all of those properties immediately applied. I'm going to draw a hidden line. Does this mean anything? Not really. But hey, look, we've got a box and a hidden line, all those properties immediately applied. Oh no, oh my mistake. This isn't a hidden line, this is an object line. I'm gonna select my hidden line and tell it to go to the object layer. All of my properties change right away. Other neat things I can do with my layers. I can lock them. Be like, hey, my object is perfect. I don't accidentally want to mess with it. I don't want to move it around. I don't want to do anything by mistake. Locked. So it fades out a little bit. So all I did was in my little layers drop down menu, I clicked on the lock. So now when I go in here, I can select it, but you'll notice my control handles are all gone. So I can still snap to it. If I'm drawing on a different layer, I can go, hey, yeah, I'm still snapping to my objects like I did before. That's no problem. But I can't modify this layer. Protects me from messing up things that I think are perfect. I can also turn off or freeze a layer. So if I go, the hidden lines are making it really hard to see, let's turn them off. Oh, I'm currently working on that layer. It's yelling at me. There we go. Change layers. So I can turn my layer on and off. I can also freeze or thaw my layer. This is the difference between on and off and freeze and thaw is pretty small in the world we're working with. Freeze and thaw can be viewport specific, on and off is global. But you probably won't see a difference between those in the work we do this term. And there are a bunch of other controls down here to quickly do things like that. If I only want to look at one layer, I'm like, oh, the only thing I care about right now is my object layer. Let's isolate it. Come on. Oh, look, my whole drawing disappeared except for the layer I had isolated. So I can make everything go away except that one layer. Just work on that. I can match things quickly to other layers. So I can go, oh, I want to select a bunch of things really quickly. And then I just want all of those to be on that layer. Play with these tools as you play. Hover over them, read their tooltips. Yeah, the front. Can I make a layer with two different line types? No. That is the point of a layer, is a layer shares all of its properties. I can override something. I'm like, oh, you're on the hidden layer, but I want you to be a center line. I can do that, but that is very bad practice. Because now when I go into my layer properties and go, oh, it turns out I didn't actually want these to be hidden. I wanted these to be hidden to or dash dot. Well, now anything that I've overridden is going to ignore my changes. So now, basically, now that you have learned about layers, everything should be by layer. If you find you want a different kind of line, make another layer for that different kind of line. And you will see an example of that and the frog exercise. Hello. Um, so this is an interesting question. What is the normal color? Everything is printed in black ink on white paper. There are ways in AutoCAD to explain to it not to print in color. To go, hey, all of these colors are actually black. They're just so we can visually distinguish on the screen. So if we're looking at it in AutoCAD, it's a rainbow, but if it's on paper, it's black and white. We're not going to get into that. So all of your drawings should just be in black and white. So you really shouldn't be changing the color, but you should know how. The one other thing I want to talk to you about is a useful tool with relationship to dimensions. So I would like to dimension this shape. I have a dimensions layer, so I can go to dimension, and I'm going to put on a dimension. Cool, there's a dimension. It's a very bad dimension. And then I'm going to draw some more, so I switch back to object, and I'm going to do some lines. Okay, yeah, do. And then, oh, I want another dimension on here because I want to know how big this turned out, so I'll slap down. Oh, but now, oh, that's kind of a pain. I have to keep flipping back and forth between dimension and object and dimension and object. Wouldn't it be nice if all of my dimensions always went to the same layer? Somebody thought of that. Under annotate, you can tell AutoCAD what layer you want all of your dimensions to show up on. Either use current, which will be your currently selected layer, whatever you're currently drawing in, or always show up to another layer. Best practice from this point forward, when you first start a drawing, set up a couple of layers, probably object, hidden, and dimensions. And now, anytime I put down a new dimension, it will show up on the dimensions layer. Even if I'm drawing in a different layer. So I can go, hey, let's draw a line. Oops, escape line. I draw a line, and I slap down a dimension. On that line, did not change my layers. It's on the dimensions layer. Yes, the back. Oh, we have a front. Hi. Oh, type in line weight. There's also one that's LT weight, but if you go into line weight, you get this little checkbox. You can also tell it how thick to make those lines. So right now they're real thick, but I can thin that down with that slider. All right. I want you to jump into that frog layers exercise. Give you about 4 or 5 minutes, and then I'll do it quickly with you because we're burning time already. Yes. Set it up on MTE 100. The 121, I must have misclicked when I set up the groups, and yeah. Why don't I share that with the class? Hello, everyone. I've been informed that I misclicked when I was setting up the robot groups on MTE 121, and it automatically assigned you to groups on 121. Ignore that. That was a mistake. Just set yourselves up on MTE 100, and we will worry about fixing the 121 later. We'll probably just go delete it. Like we'll just delete those groups after this, and then set them up again. Well, I guess we'll make an announcement after we fix it. All right. And looking at the time, this seems like a good time for a break as well. So if you want to take 5 minutes, have a breather, go to the washer, get a drink, and be back at 25 after.
five dominoes in a straight line. So how do you tell it, like, how do you tell it, like, the patterns that you lay it in? How do you tell it to start, stop? Just add a bit of nature to it. Like, a mechanical system that lays 10 dominoes, absolutely good enough for your mechanical system. Adding a little bit more to it for decision making, you'll need the computer programming stuff.
So you said at the start of the class you're gonna have everyone free come Friday and just maybe resolve.
Yeah.
At the I assume you're just gonna kind of round up the stuff.
Yeah, we're gonna round.
If you have a group of three, like two against two, you would just round the other up and find one other person.
Yeah, just make a group again.
Yeah, but just
Yeah, yeah.
you don't mean like, okay, we're gonna forcibly separate.
No, we're not gonna forcibly separate you. It's one of the things we often find is we get like 10 groups of three, and then we just if we just force somebody into that group, it's a group of three, and one person doesn't do anything. They're invisible. So if we're like, no, you need a group of four, go find somebody that you can work with. It works out a little bit better.
Oh, okay.
And also knowing that, now between today and tomorrow, you'd be like, we should find somebody. Maybe we've got a Discord for the class where we can go, hey, looking for one person. Thinking about doing X.
All right, my wee darlings, let's get back at it. Are you ready for the wild and exciting world of dimensioning? Yeah. Feel the enthusiasm in the room growing. So we have talked about dimensioning sort of on and off continuously all term, but I really want to formalize some of our rules. You've got enough tools, you have enough understanding of shapes that these will start to make sense. A few notes, historically, traditionally, students, first year students, young engineers, are terrible at dimensioning. And we try to correct that, but we will be unable to, in this course, to make you excellent at dimensioning. What we can do is give you guidelines and guidance and hope that you continue to grow. We could spend this entire course doing nothing but critiquing your dimensioning and making it better. Dimensions are the grammar of manufacturing. They're how we describe objects to other people. And so there is a grammar to dimensioning. Like grammar, as very much like English grammar, there are rules. There are absolute rules set in stone that you barely ever follow because we break them constantly. So what we're going to do is give you a bunch of guidelines and standards. These are based on the ASME, American Society of Mechanical Engineers, the ASME dimensioning standards, best practices, guidelines. Almost everything I'm going to say today is going to come with the phrase wherever possible. This is going to feel a lot like the I before E except after C rule. Follow these rules except when you can't. and then you have to use your judgment. But before you can use your judgment, you have to know the rules. And so, let's dig in to dimensioning. Remember, as we dive into this, the purpose for our dimensions is to communicate our design intent. How is this thing going to be made? How are things going to connect together? A good dimension has only one interpretation. And a well-dimensioned part clearly has all relevant sizes and shapes defined once, and with no ambiguity. That is our goal. Absolute clarity in translating our design intent through dimensions. Some nomenclature, some vocabulary. Dimensions have parts. So when I say a dimension, I mean the whole thing. But dimensions have parts. We have the extension line, which is a straight line leading from whatever we're dimensioning out to our dimension line, which is the thing with the arrows on it. Our dimension text, I bet you can guess what that is. Center marks, we talked about those. The real ones that I want you guys to remember: extension lines, straight line that's extending from our objects or from the things we're dimensioning. Dimension lines, the bit with the arrow that go between those dimension lines and are orthogonal to the extension line. So dimension line, extension line should be at right angles. Yeah. Very. How important are the small gaps? Well, there's a whole rule about that. This small gap is very important. They reduce confusion because then it's much harder for us to mistake an extension line for an object line. That gap gives us a visual break so we know for sure they're not the same thing. Yes? We will talk about AutoCAD dimensions right after we talk about dimension rules. I have uploaded a document with all of these and more to learn. You are expected to review everything in there, know them, understand them, and apply them to future dimensioning assignments. So, going through some of the critical ones, and I'm going to go quickly. First, every dimension should be clear. We can interpret it only one way, and we want to keep them off the part whenever possible. So that is to say, the dimension text does not appear on top of your parts if you can avoid it. Sometimes you can't. This part, no problem. If this part was very, very big and all of our, we'd have to have an extension line that was like this long before we got to our dimension text. Well, that's not adding to clarity, that's reducing clarity. We might change our mind. But typically, dimension text off your part. All dimensions for a specific feature should be, if possible, denoted in the same view. So if we're looking at this part, we've got these two concentric circles. Well, what's going on? They can't both be holes. That doesn't make sense. So what we have is a hole in the center and a counterbore around the outside. If we add a little depth arrow, 10, this now tells me that this outer circle is diameter 30, depth 10. And now just looking at that one view, I know both things about that feature. Dimension line should never be joined to the end of any line of the drawing. Dimensions should be spaced uniformly, and they should be more distant from the part than they should be from each other. So these two are a little bit too close together. This is too close to the part. We want a good distance from the part, and then a smaller but meaningful distance between the dimensions, mostly so the text doesn't overlap and it's easy to read. All of this is about clarity and legibility. It's like having neat handwriting. Longer dimensions should be placed outside shorter dimensions to avoid crossing. We'll have another rule later about we do not have crossing lines when possible. It is often necessary to cross extension lines. Do not cross extension lines over dimension lines. This is always bad. Wherever possible, keep your dimensions dimensioned to extension lines, not to object lines. So in this one, we want to drag this dimension off the part. So we're not dimensioning directly to the part. Do stop me if you have questions about these. I am flying through, and we can go back if we need to. When we dimension things in multiple views, figuring out where to put those dimensions can be challenging. In general, when we can, put dimensions that relate to multiple views between those views. So this length along the bottom and this length along the side here, those are the same length. We don't want to dimension both of those. We just want to do one. So if I put one dimension between the two views, I can see that it lines up and that those are related. I don't want to have my lines extend down to both. That's weird and bad and will cause you all sorts of problems, especially if you have multiple dimensions. Avoid dimensioning hidden lines. There should almost always be a better view where you can dimension the true object in the in object lines rather than attempting to dimension to the hidden lines. Again, when you are picking which view to dimension things in, try to pick the view where the object actually exists. Similar to the hidden lines, we can see very clearly this shape. And so all of these dimensions in black are preferred to the ones in red. It doesn't, like you look at it and it's like, well, it's the same thing, but it's a little bit more clear in this view what this 0.75 is referring to, what aspect of this object it's describing than it is from the top view. I have to do a little bit less work in this view here than in the view up above. Yeah.
For the ones in the top view, like yeah, that one in power. For that, what's the big deal about that?
Honestly, this one probably just shouldn't be here. We'll talk about redundant dimensions in a second. But that's a really good question. It's like, which one do I put this one in? In this case, doesn't matter. But it is bad to have it in both. Dimension the true shape of things. So in normal orthographic projection, if we took this triangular prism and rotated it from this side view to this front view, this hole that runs all the way through it, that we can see in this auxiliary view, gets projected into an oval. We don't want to dimension that projection. I want to dimension where it is flat on and I actually have a true circle. Which means sometimes we need to add extra views so we can dimension that way. Dimensions should not be duplicated. So remember that one that we saw in two different views? Bad. So if we had both of these dimensions, then we would be over-dimensioned. We're redimensioning the same thing. Sometimes, for clarity, it's nice, or for convenience of whoever's working with it, it's nice to have some redundant dimensions, but we can put those in a redundant dimension in parentheses, and that communicates, I know this is an extra dimension. This is the one that really matters. This is the one to look at first. This one's also true, but these aren't in conflict. This is just a redundant or duplicate dimension. Don't break your lines over object lines. Your dimension line or your extension lines can cross right through object lines. That's fine. And here again, avoid crossing dimension lines at all. Rearrange things so your dimension lines do not cross. This one, only relevant if you're doing continuous dimensioning. But if we have a chain of continuous dimensions, usually it's better not to do a full chain, but to do a bulk dimension, or like a full envelope dimension, so we get the full size of the part. Because very often, the first thing we need to do is cut out a piece to then start working on it. So if we're machining metal, we cut a piece of stock to the right size, and I don't want to have to do a bunch of math to figure out what that size is. It's nice to have a dimension that tells me what that is to start. So having a bulk dimension on my part, super useful. But if I had both that and the full chain, it would be redundant. So we can, again, add in, if we want both of these, we could put one of these chains of dimensions in parentheses. I would put the least important of these in parentheses. So if two of these, say these two extended bits, are mating components, and they have to have a very specific size, but this little divot in the middle or this little bit off the end doesn't matter so much. It can just be whatever's left over after we get the things that matter correct. I would put the parenthesis on the one that matters the least. Because basically being in parentheses means this dimension is a side effect of all of these other dimensions. It's a consequence of that math, rather than it itself being critical. But we dimension in baseline pretty much exclusively in this course, so all of that becomes kind of irrelevant, except the bit about redundant dimensions. This is a fancy way of saying make sure your dimension text is legible. That's it. When you print, remember that people have to read your dimensions, and some of those people are old and have bad vision, and so if you make your text tiny, we can't see it, and we get grouchy. Radii are dimensioned with an R. Diameters are dimensioned with the diameter symbol. Circles, holes, complete rounds are always dimensioned with a diameter. Partial rounds are dimensioned with a radius. We dimension the center of holes and typically the center of all round objects or round items rather than to their edges. If we have several repetitions of the same object, there are some shorthands, so we don't have to dimension, say, all 4 of these holes with exactly the same hole callout. So here you see it's got the hole callout, 10-24 UNC, 1.5 inches deep, typical 4 holes. That typical 4 holes means, hey, all 4 holes that look like this one follow those same instructions. This only works if there's no ambiguity. So same thing here, we've got our fillets here, radius 0.5, that tip, TYP, let's zoom in on here, that TYP stands for typical. That means if we see a fillet that looks anything like this, it's going to be our 0.5. This only works on parts where this is unambiguous. If anywhere on this part I've got like a 0.45 radius fillet, or even a 0.3 or a 0.6, I couldn't do this. I'd probably have to do them all individually. Leaders, that is lines with arrows on the end. If they are pointing to anything circular, they should point to the center of that radius. And at the end, by our standards, we should have horizontal text. One of the options we can have is your text aligned with the leader, or does it jump over and be horizontal? In ASME, we prefer horizontal. Occasionally, you will throw down dimensions that are not to scale. That is to say, the part on the page, whatever the drawing is, isn't scaled. If you go back to that clamp we had at the beginning, it had one dimension that wasn't to scale because we shortened the shaft so it would fit on the page. There's two standards for that. One is just underlining the dimension. The other is writing NTS, either right beside the number or underneath. So NTS means not to scale. You don't have to write this extra thing. This is just explaining what the NTS means to you. Blorp. Too many animations. I really need to redo this slide because this has some redundant dimensions on it. Non-45 degree tapers are typically dimensioned with a length and an angle rather than two lengths. So this one has length, angle, length. We really only need one or two out of three of these because the third one's just a consequence of the other two. And this is a decision based on what is important. Is this length important and this angle? Or is this length important and that relative angle? The way we've done this, I would say the 2.3 and the 27 degrees are the important aspects to me, the designer, because that's how we've made the angle is the 27. And the 1.2 is probably less important. I could delete that. Center lines. Up until this point, we have only used center lines as indicators of the center of an object, as the name implies. That is, we've got a circular object, let's put a center line down the middle, helps us know that it's circular. You can also use them as like a mirror line on a symmetrical object. They're also used to indicate alignment. So these two holes are aligned along that center line. These ones are aligned along the same center line, which means I don't have to dimension all four because the center line is telling me they're aligned horizontally with each other. So we can reduce the number of dimensions we use. There are a few options on how to dimension symmetrical things. So in this case, these are symmetrical about the center. And if I care about the distance between them more than anything else, I might dimension them like this and then have a little note that everything's symmetrical about the center. See, dimensions are centered on plate center. If, however, what I care about is the distance from the center of the plate, I might dimension them like this. I may also dimension them like I do on the right. And you'll have different preferences as to which way we do this. This one is unambiguous but cluttered. This one may leave some room for interpretation, and I have to do a bit more reading to figure out, oh, what is the dimension of this hole? But both give me all the information I need as long as I got a little note on this one that says it's symmetrical. Yes, at the back. Yes, the outer circle is our major diameter on threaded holes. It should be, but it typically isn't. In SolidWorks it'll do it for you, but often the inner hole is just done by eye. It's just so it's visible. And this is just a quick note that there is yet another kind of dimensioning that we haven't looked at called ordinate dimensioning, where we just drag off individual numbers, and this is an indication of how far we are from the datum. You might see these more in architectural drawings and plan views rather than manufacturing drawings, which is our focus. Yeah, the back again. What were you working on? Manufacturing? You had ordinate? Oh, interesting. Yeah, I don't see it very much in parts drawings. It works best when everything's very orthogonal. As soon as you get angles to things, or ordinates gets a little weirder. All right. That was absolutely a breakneck crash course in dimensioning rules. Any of those you want me to go back to and go into more depth? No, because you're all. Oh, yes. Oh, that's a great question because the next thing we're going to do is talk about dimensioning in AutoCAD. You guys are really good at the segues today. All right, so let's talk about dimensioning in AutoCAD. Oh, I don't have it open yet. So you'll notice I definitely changed my order of operations today at the last minute because exercise 2 is the one we're doing third. All right, so dimensioning in AutoCAD. If it's all set up nicely, we throw down a dimension and we can use our little dimension button here. This dimension with the star, the little sunburst under it, this is our smart dimension. I'd say like middlingly clever. Smart's a little strong. Because when we use that, it's going to guess what I want to dimension. So if I hover over a line, it's going to try to dimension the line. If I hover over a radius, it's going to, or a diameter, it'll do the diameter. Radius, it'll do the radius. Usually, probably, most of the time. If I've got a snap, it'll get my first end to that snap, and then wait for me to click to the other end. Blorp, blorp. We can also force the matter, which I often prefer to do. Because in the smaller button beside, I have a drop down of the kinds of dimensions that I might want. So if I want linear dimensions, that is like nice and lined up with my axes, I can force that. And then even on funny angled faces like this, I know it's going to be one of my orthogonal dimensions. If, on the other hand, I want it to be aligned, I can grab this aligned one. Go, I really want this line. There we go. Snaps are your best friends with dimensions. And of course, we have our angular dimensions. Where's an angle? There's an angle. Oop, oop. Pick 2 lines, drag it off. Depending where I drag it, I'm going to get it looking different. Again, my goal, have it off the part. Tell me the thing that I want it to tell me. Oops, I've made a mistake. What is my mistake in this part? Yes. I'm dimensioning to an object line. I don't want that if I can avoid it, so let me drag it a little farther, and now I've got full extension lines. Yay, I'm behaving myself. The thing that you are going to find in AutoCAD is that when you start up a new drawing of your own, the dimensions probably won't look the way you want. Just like we had text styles, and the default text style may not be what you want, the default dimension style almost certainly isn't what you want. So if I go in here to my annotate, I look at my different dimension styles. There's only one here at the moment. Let me go manage those styles. So I can create a new style. I'm going to make a new style that is a copy of my standard. I'm going to base it on my standard. And then I'm going to mess with this a bit. So when I modify a dimension style, I have many options as to how it appears. And this is all about just how it appears on the screen. Because we're always dimensioning the same thing, right? It's just, what is this number? Here, I can tell it what color to be. Do I want to suppress some aspect of it so my dimension lines only come off in one direction? How far apart should things be? How big should my extension lines be? How far should they extend beyond the dimension line? How big a space? So let me change some of these around. And as I do this, you can see different aspects of this are changing. Symbols and arrows, we're only ever going to use closed filled, but hey, We've got all sorts of choices. Are you in architecture? Let's have architectural ticks. Do we want to change our arrow size? Sure thing. How about our text? Where do we want it? Do we want it aligned with our dimension text, or do we want it all to be horizontal? Do we want our text to be above our lines, below our lines, centered? Well, typically we want them centered in what we're doing. What if things don't fit? What do we prioritize? How many decimals do we want to appear? Currently we have 4. Do we want none? Do we want 2? We can adjust this. All of these things are things we can play with. I would recommend the first thing that you play with if your dimensions don't look right is to go to your fit and look at these scale for dimension features. Because we can just scale the whole thing up or down before we start messing with the little details. So I'm going to say I want to use an overall scale of 1.5. Whoop, nope. 1.5. So that's just going to scale all of my dimensions up. All right, so now I've created a new dimension standard. Let's have a look at what happens if I use... Wait, did I fail to save? Oh, sorry, there we go. Looking in the wrong window. So we've got standard, and we've got the copy of standard. So let's throw down another dimension on this rectangle down below with my new dimension standard. And it looks completely different. We can adjust every tiny detail about our dimensions, and we can have multiple dimensioning styles in case we have dimensions we want to look one way or the other way. All right, I think that is enough. As I tell you to work through this one, I super don't care about the this kind of leader, but if you read the instructions, it will tell you how. This is a multi-leader. This is a normal leader. I think everything else in here you should be able to do. So go ahead and take a run at it. This is one of those things that I can tell you these things over and over again, and they won't make any sense until you actually start working with them, trying to dimension something, and are actively making those decisions. Oh, yeah. Do you not know how to fix it yet? Okay, so AutoCAD. Oh, yeah. No, that's my 3D. Stay close this one. Print AutoCAD. You don't have AutoCAD on the screen. Yeah, that's annoying. I do not have access to
Adding an extra object.
this is not a week. It really is. You're right. You're right. I just changed the line.
I think it depends on where you go. Every workplace has its own set of
Okay,
standards
so
depending on the standard way. My first job, I worked in a transmission company. They made transmission sets. So they were very much like about Vegas. Because it gives a great appreciation that yeah, but it's extra capital. When they want precise money, they will try to go Vegas and
what does the inventor did?
Trim will just get
Oh, um, Better is, but I do not know. I'd be curious if you can find it, but oh, break at point. So in the modify menu, drop it down, break at point, I believe is what you're looking for.
All right.
Just looking at the time, I think this is a good time to take a 5-minute break on topics, and then we will get into the last section of the class a little bit early, which is great because I've jammed way too much material in today.
First year doesn't have a lost and found. We do. We have a lost and found. First year engineering office doesn't have a lost and found.
Because the last time the person who lost his wallet, they gave it to the person who
And they contacted the owner of the wallet. That's a different scenario.
Yes. Yeah, we've got a lost and found. The cabinet right inside has got some stuff in it. And Sock's got a lost and found. Sort of. We don't have a central one.
if she's checked the V flower in here, then is there any other place she could check?
Campus is big. Every room you've ever been in, and every room somebody who might have picked up your mouse and then left it somewhere. It's not a good answer. Yeah, sorry.
All right, if you want to find your way back to your seats, let's get on to the next exciting portion of our lesson. 1 second, let me get my slides up and then I'll answer your question. Ooh, spoilers.
Yes.
What's up? Typically, no. Try to avoid it, but sometimes that's the best solution. But usually, no, like your arrow should be pointing to the object.
Right. For like, not for external fillers, that's easy. That's easy for internal ones. It's a little harder, unless the entire arrow.
That's one of those things where you're gonna have to make judgment calls. Yeah.
Matters we get if I do it.
So diameter tells me it's a complete circle. Radius tells me it is not. So if the circle does not go all the way around, give us a radius. But if it's like a half circle, we get half circle radius. That would make sense. Yeah. And that's sort of a way of communicating, hey, this circle's not complete. Or if you've got a circle like diameter symbol, it's like this circle is complete. You don't have to worry about doing anything weird or special, just get it through. We're not using them, we're talking about them. You know, if you have them, you can play with them, but depending where I place things, AutoCAD shows me. Oh,
All right. Are you ready for Tool of the Week? Clearly everybody's favorite part of this class. Next year, no AutoCAD, no drawing, just tools. We're going to talk about every wrench that exists. All right, vernier calipers. Woo! Woo! That thing I've been telling you to buy for 3 weeks. You really need to get them because there's an assignment this week. If you have them, you might want to pull them out so you can look closely at them. If you do not have them, there will be pictures. These are vernier calipers. And to make your life incredibly complicated and difficult, these are all calipers. A caliper is any measuring device that measures a linear distance by butting two hard things against the edge of a thing. And so we have a whole variety of calipers on here. We have inside, outside, divider, odd leg, and depth calipers. So outside calipers measure the outside of things. That's all of these outsidey grippy ones. So you'd put this on the outside of something. Inside calipers measure the insides of things, and so they have their measuring faces facing the other way. Dividers usually measure on the surface of something. So they have 2 points pointing down. This is also an outside caliper. So is this thing. We'll talk more about these later. They're called micrometers. But these are all calipers. Odd leg calipers are things like this, where one leg is longer than the other. This we press against one face, and the other one we slide along until it meets another point. So these are all calipers. To make things even more complicated, these are all vernier. Vernier calipers, despite the fact that most of the time if you ask somebody in a shop for calipers, they will hand you these. If you ask for verniers, they will hand you a set of these. That is kind of wrong. So these are calipers, and they are the vernier part of them is the scale. Vernier scale refers to the way these dashed lines line up, how we read these specific kinds of tools. So we'll get into more details as to how to read this, but the vernier part of it is named after a French guy, which is why you will hear people refer to it as vernier, because they don't know it's French. Vernier, because you went to an Ontario public school and have very poor French, or Vernier, because you might actually speak French. These are not all vernier calipers. Now that you know that it's only the scale that makes it vernier, there are different kinds of calipers. Technically, these are slide calipers. Sometimes, very rarely, multi-action slide calipers, if you look up an ad for them from like 1890. If you ask for vernier calipers, sometimes somebody will hand you a set of digital calipers. We kind of know what we mean when we say vernier calipers, but we're kind of wrong. Yeah. Is there anything that vernier calipers offer that digital ones don't? Waterproofness. That's basically it. Digital calipers are in almost every way the same or superior to vernier calipers. At least good ones are. The thing that vernier calipers are tough. Me personally, when I work in a shop, I have a pair of these in my back pocket, and I don't worry too much about it. My digital calipers, I keep in a plastic box with a foam padding. They're much more delicate. You drop them, you've ruined them. I have dropped these many times. So these are more robust, certainly, than dial calipers and digital calipers. It's basically the benefit of them. The reason I'm forcing you guys to all use vernier calipers this term is, well, we'll come to that. But the big one is they're very cheap. You can't get a $5 set of digital calipers that I'm aware of. All right, let's talk about how to use them. So, dot cam, boom, 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 boom. Okay, so we have some calipers. So here's my set of digital calipers. You'll notice they have lovely features, and when I make them big or small, I measure distance. I'm going to use these to demonstrate how to operate them on an object, because it's much easier for you guys to read them on the screen and see what's going on. So I can use these as an outside caliper. These jaws here are my outside measurement. Outside. The jaws are sharpened. See, we've got this sharp edge here, this sharp edge here.
So a little bit of a slant is less of a problem. So if I'm a little bit cocked, I'll get a better reading on the sharp faces. So there we go, 0.14865 inches. Let's flip that, see it in fractional inches, see it in millimeters. Isn't that convenient? These faces that look a little bit like a beak when they're closed, those are my inside calipers. I can put those inside an object. Give it a little wiggle. There's my inside measurement, 25.37 millimeters. This little rod that's sticking at the bottom is a depth gauge. I can measure the bottom of this relative to the bottom of this. Because you see, when they're closed, they line up. So they're flush like that. So their relative distance will give me depth. So here I have this piece of metal. So if I butt it like this, I don't know how visible that is on the screen. So I've got my little extendy guy all the way butted up, and then my lip is 6.85 millimeters. I also have a thumb screw here to tighten if I want to lock in a measurement. So I can take my measurement. Maybe if I want to, again, use my depth gauge and find out the depth of this, I'm going to slide my rod all the way down until it hits the ground, lock in my measurement, and then I can read it. Wander off, write it down. Your little plastic ones don't have that. That would have cost an extra $1. Some slide calipers also have what's called an odd leg measurement. You don't use it very often. You see how these top two faces are also flush? That means I can measure the distance between the two top faces. I have a couple things here to demonstrate how. So what you use an odd leg for is if you have a lip on a surface, I can butt one edge up against there and slide the other one, oops, this one's a little more awkward, up to meet, and then read off my measurement. It's much more rare. Many calipers don't have that. If I drop my stool, if I grab my vernier calipers, you'll notice I don't have those flush lapped top faces. I can't do that measurement with this one. It's non-standard and not super useful. Every now and then it'll come up and be helpful. So yeah, that is why these guys are so popular, is that there are four measuring tools in one. 3 or 4 measuring tools in one. Bloop. Right. My slides are helping me keep track. Yeah? Oh, this is just a conversion chart. So let's see if I can maybe, let's get a bit of light on it and zoom way in. So this is not, I think this is just the company trying to add extra features. They went, oh, it costs us 4 cents to print a bunch of numbers on the back of this plate. Now we can make this an additional feature. But conversion charts are convenient. So yeah, it's just conversion between fractions and decimal. If you have good eyesight. I can't read this. Oh, to be young again. Alright, whippersnappers, let's talk about the vernier part of this. So, the vernier scale. Let's get something pointy. This is pointy. Alright. So you will notice on the vernier scale, how do we read vernier calipers, or vernier scale in general? Well, the straightforward, we look at our 0, and wherever that 0 lines up with, that's our base reading. So if I just slide this over here and go, alright, that's, well, let's make a real easy one. See how our 0 is lined up with the 1? That means this is 1 inch. Now it's, if we look at, and how this particular one is set up, the bottom is decimal inches, which is what a lot of machinists work and the top is fractional inches, down to 1/128. So I'm gonna focus on the decimal inches. So here we have 1.1. Trying to get it nicely lined up with the 0. 1.125, because this is a quarter of the way between the 0.1 and the 0.2. So 1.125, 1.15, 1.175. But, and this is where the Bernier part comes in, what if we wanted to measure how far between 1.1 and 1.125 we are? I'm going to slide this all the way down, and you'll notice these lines don't line up with the lines above them. There are a different number of lines on the top as there are on the bottom. Specifically, there is one more. What that means is as I slide this between 0 and the next tick mark, the other lines are going to cross each other and line up at different parts. See that one lined up, and then this one lined up, and then this one lined up, and then this one lined up. I have a bigger tool that will make this more visible. I made a very big Bernier scale. All right, so 1 inch. And you'll see none of the others are lined up. Our quarter, our 2/4, our 3/4. These ones don't line up, but our 4/4 does, because that's 1 full inch off, right? And you'll notice there's 5 ticks here to 4 ticks up above. That is the wizardry of the Bernier scale. Just having one more evenly spaced tick below than above. So as I slide between 1 and 2 inches, 1/4, then 2/4, then 3/4 will line up with one above. I'm a quarter of the way along. I'm 2/4 of the way along, or half. I'm 3/4 of the way along. I'm all the way along. I'm now 4 out of 4 quarters from 1 inch. Or, alternately, I've made it 2. So that's the whole genius of this. I can measure fractions of a division on a ruler using a Bernier scale. So there, oh, hey look, I'm at 3 1/4. I'm at 5 3/4, because the 3/4, because it's 5 plus 3/4. Let's do this on your micrometer. Yeah, that one's more readable that way. So, not your micrometer, your calipers. All right, pointy thing. So let's think about millimeters. I'm going to pull off a measurement here. So, I am at 10 millimeters, 11, 12, 13 millimeters, and a bit. And what the Bernier scale is, oops, be nice if there was a thumb screw. What the Bernier scale is going to help me do is figure out what that bit is. Actually, this might be useful. So, I'm at 12 millimeters and a bit. So where do these lines line up with each other? So I'm going to sort of drag this guy along, and you'll see, oh, those two lines don't line up. Those ones don't line up. This one's getting close. Oh, this one looks pretty much spot on. And this one's a little bit on the other side. And so, that right there, and it keeps moving because this is very jiggly, these two line up with each other. Which means my measurement is 10, 11, 12, so 12.25 millimeters. So I can measure down to fractions of a millimeter, 1/2 a millimeter, a 20th of a millimeter on this scale. Like magic.
will hopefully help illustrate if all of my illustrations have not. If I can get my PowerPoint presentation to show up on the, oh, right. Boop, boop, boop. Gift time. A little fun fact. Our calipers here can measure, or my calipers here, yours measure 1/28 of an inch, but this one measures thousandths of an inch, which is a really common sort of basis that machinists, that precision machining happens in. Yeah? Sorry, you have what? Yeah, dial calipers will do thou as well. Well, basically all good calipers will do thousandths of an inch. Yours are $5. Thou, if you ever hear somebody say thou, that is often a shorthand for thousandths of an inch. Inconveniently, mil is also shorthand for thousandths of an inch. Because mille in French is thousand. So it's short for thousandths of an inch. Really inconveniently, sometimes people will say tenths to mean tenths of a thousandth of an inch. So in precision machining, a tenth is not a tenth of an inch, it's a tenth of a thousandth of an inch. You're welcome. It's not my fault. So why are we talking about this? Besides the fact that it obviously delights me to no end. Because we need to talk about precision. We use the word precision to mean a whole bunch of things. I say precision machining. What precision is your drawing to? Colloquially, we mean precision in all sorts of ways. Sometimes we mean accurate instead of precise. Sometimes we mean expensive. Technically, in metrology, the science of measurement, precision is the ability of a device to provide repeated measurements of the same value. So if I took the same measurement 5 times of the same thing with this tool, what range of values would I get? In EGAD, when we say precision, we usually mean the number of decimal places, or another way of saying this, the smallest fractional unit that you are dimensioning to. Now these two are related. The good definition of precision and our decimal places, because when we dimension to say 3 decimal places, that dictates the tools that the machinist needs to use to machine that object. Because you're saying you must be able to get this correct. So let's talk a little bit more about that. So, quick refresher, accuracy is correctness. So accurate means actually right. Is it the right answer? Precision is about reliability. Did I get the same answer every single time? Even if it's the wrong answer, am I getting the same wrong answer every single time? And have a precise tool that is wrong and an imprecise tool that is basically correct. Resolution is another thing we often mistake for precision. Resolution is what is the finest measurement that your tool can distinguish. So on these calipers, I can distinguish 1/1000th of an inch. That's the resolution. On our plastic calipers, I have 1/2 of a millimeter and a 1/28 of an inch. I've got 2 scales. Those are the resolutions of my tool. They are not the precision. For most tools, they are more precise than their resolution. So, in theory, every time I take a measurement with this, it's going to give me the same measurement because it resolves thousandths of an inch, but it's built so well that it could resolve a finer differentiation. So the precision is within my resolution. With these guys, it's not. These have a resolution of 1/20th of a millimeter. But depending how hard you press, the little jiggle in here, how many times you've slid them back and forth, whether or not the jaws are a little bit worn out, you will get a range of measurements of plus minus about point, at least these ones are about 0.4 millimeters. So the resolution, like that, it has an 8 times better resolution than precision, which is bad. But it's one of the reasons I want you to work with these is to sort of recognize that conflict. Go, oh, I keep taking measurements and I keep getting a different number. So what number should I actually record? I can't meaningfully record it down to a half a tenth of a millimeter. Because every time I take the measurement, it's not the same number. So what can I actually meaningfully read off of these? On a drawing. Let's jump back over to our drawings that we're going to be trying to make. The number of decimal places you have imply a precision or a tolerance. So let's define tolerance. I probably should have had another slide just to define tolerance. Tolerance is our acceptable results. Whenever I make something, it's not perfect. It will never be exactly the number. If I say make this 10 centimeters, it will come back. It will not be exactly 10 centimeters. It might be within a couple atoms of 10 centimeters, but it won't be exactly 10 centimeters. And so tolerance tells us what range of acceptable values around our nominal value are acceptable. So if I say I would like this to be 3.12 centimeters, the implied tolerance is anything from 3.11 to 3.13 would be acceptable. And anything outside of that, we need to either go fix or destroy. We have 3 decimal places, plus minus 0.005. 4 decimal places, 0.0005. We almost never dimension to 4 decimal places. We were talking about thousandths of an inch, right? Those are very small. Dimensioning to tenths of thousandths of an inch is only in the highest of tolerance things. Yeah?
You gave the example that the range would be from 3.11 to 3.13. Is that range inclusive?
Typically inclusive. But you would have to shy on the low side, so often we would throw out something that actually hit that threshold, because then we have the precision of our tool measuring it. Error in that side, we might go, I'm not actually sure it's within spec. Oh, spec means specification. Within specification means as defined, as required. Angles usually plus minus half degree. So these are implied general tolerances. If we don't have anything specifying this is sort of what you can guess. Many drawings will have this, the implied tolerances given. So if on a drawing I see something dimensioned to point X, that's plus minus 0.5. In this case, millimeters. That drawing we saw from Spar Aerospace of the motor housing had one of these. When they're dimensioning an imperial, these are our tolerances. Trying to give you a bit of a sense of scope of things, a piece of paper, one piece of paper is about a tenth of a millimeter, and it's about 4 thousandths of an inch. So when we're talking about a thousandth of an inch, that's a quarter of a piece of paper. Do not dimension to 4 decimal places. Let's go back to this exercise. This, if we're in inches, says that this needs to be 3.7359, probably plus or minus 5 tenths. That's, you know, an eighth of a piece of paper that we're trying to, that we're implying the tolerance of. Does this shape need to be precise, like accurate to within an eighth of a piece of paper? No. At best, we should probably be in the thousandths, usually less. And this is a thing that industry to industry, project to project, you're gonna end up with different tolerance levels. If you are working on like the James Webb Space Telescope mirrors, you might be working to like a finer degree than this. You might be in like hundredths of a thousandth of an inch. You might be working in micrometers, but usually you're working in like tenths of a millimeter, maybe. That's pretty precise. If you're working in wood, you're usually working to like an eighth of an inch is your tolerance. If you're framing a house, that's even a bit like that's a bit restrictive. I've lost my slides. There we go. Again, do not dimension to 4 decimal places. Very rudely, one of the standard dimensions that comes up in AutoCAD is 4 decimal places. Don't know why. I think it's just too annoying learners of AutoCAD that all of their dimensions are terrible. This is just a lovely quote. When we're talking about tolerances and dimensioning and making sure your drawings are precise and accurate, get that right. A object lesson. When we were building the LRT here, they built some of the platforms, and then they looked more closely at the train and realized the train did not fit and would shave off its side every time it would try to drive by a platform. I don't believe they ever actually drove the train past these platforms. They figured that out after, but they'd already poured the concrete. Some bad dimensioning led to having to carve off the side of poured concrete and re-pour it so that the train would fit. Do good work. Oh, I find this a deep and fascinating topic. Come ask me about it another time. But strive, generally speaking, when you're designing things, design things to nice round numbers. It makes it easier for basically everyone involved. Especially for things like holes. If you're like, I want this hole to be 7.923 millimeters. And your machinist will go, I don't have a 7.923 millimeter drill bit. This would take me all day to machine that hole. Can you just make it an even 8 millimeters and have it done? Sometimes you can, sometimes you can't. But when possible, make even numbers. The interesting side effect of this is the world we live in is built using nice round numbers. The things that you pick up, the thicknesses of the things you carry and you hold, the sizes of your cell phones. These are all based on the unit systems they were designed in to be nice round numbers. So depending whether you are sort of North America and influenced by America's inches, or you come from a place that is very metric centric, you will find that you are better at estimating certain sizes of things because you're so used to them. If you go and pick up just like a coffee cup from a country that uses inches and a coffee cup that uses centimeters, they'll feel weird and different in your hand. We in Canada, we're surrounded by things that are designed to inches. Even things that claim to be metric, that's just an after the fact conversion. Most of our cans are like, if you pick up a soup can, it's usually 3 inches or 2.5 inches across. And so we get kind of good at estimating inches because we're so used to interacting with things that are about an inch or 2 inches or 3 inches or 6 inches. And we tend to be really bad at estimating centimeters because our world isn't built out of centimeters, it's built out of inches. Someone comes from another place and they're like, what are you talking about? Inches don't make any sense. I'm good at estimating centimeters. My world was built out of centimeters. Fascinating cultural differences. All right. I need to really quickly edit a slide. Any questions about precision, accuracy, slide calipers, etc.? I'm sure even if you have questions, I'm not looking. This is incredibly rude. Whoop. Bam. All right. So, this is why I had to edit this. Give me a title block. All right. We have a quiz coming up during midterm week. You should be very familiar with this. It should be in your midterm schedule. We've mentioned it many times. It's on Tuesday, the Tuesday of midterm week. We call it a quiz rather than a midterm, just because it's only worth 5%, relative to some of your midterms, which are worth 30. And unlike a midterm, it's not what we would call a summative assessment, where we're trying to get you to prove that you can do all of these things. We're using it as more of a way to test some of the things that we haven't been able to assess in our weekly assignments kind of stuff. And I wanted to go through an exercise with you, because you should all do this exercise yourself with all of your exams. What is going to be on the exam? You should already know, because you've been here. Yes? Ethics. Ethics will be on the midterm. Or could be. I will say could be. All of these could be. We haven't written it yet. Is that it? That's the whole midterm? Yeah. Design cycle. Yeah. Shafts. Extrusions. What other things did we learn about? Bearings. Fasteners. Anything else? Yeah. Gears. Pulleys. Belts. All of these could be on the quiz. Yeah. Sorry? Tool of the week 100% counts. It's not been on any assignments, but we spent a lot of time on it, haven't we? Not just the tools themselves, but the lessons we learned from them. Was that? Yep. Writing practices. Anything else we've covered? DCAP, EGAD? Yeah. Freehand, some of the concepts that we cover in freehand, but I'm not going to require you to draw freehand drawings on the quiz. It's just not a great environment for that, and we make you do those assignments every week. But dimensioning, everything we covered this week could be on the quiz. Yeah. ISO and ortho, absolutely. Yeah. It's already on there. So the reason that I asked you to do this, I could just tell you, but the point is you already know what's going to be on your quiz because you've been doing the class. We're not, broadly speaking, your professors are not malicious, sadistic people. I'm not going to put surprising things on the quiz unless you've not been paying attention. I might put challenging things on that make you, say, incorporate multiple ideas together in ways you haven't done before. But for the most part, the contents of the quiz are very predictable because you've been in class, you've seen what we have emphasized, what we have sort of just breezed over quickly and said, it's worth knowing, but don't worry about it. Where we've made you spend your time. And on this one in particular, unlike most of your exams, we're going to focus more on the things that you haven't done lots of assignments on because you've already done assignments on them. You've proven to me that you can do like certain orthographic projections. We might have a bit, but it won't be the focus. I made a list as well, just in case we missed anything. Yeah.
Sort of related, but will we get our quiz results back for the two that
Oh, yes, I think so. We've been holding off returning the quiz results because there's been a couple people that showed up late for all sorts of complicated life reasons, and returning the Learn quizzes would have been awkward. I think we've got all those knocked out yet, or knocked out now. We also found an error in a question, which we need to figure out what to do about. So before we return a bunch of grades that are wrong, we need to correct that. So yes, we will get those back to you probably over reading week when we have a bit of breathing space. Because I don't know if you've noticed, it's been busy. Y'all look tired. I'm tired. So let's talk about reading week. Oh yeah.
Do previous exams,
Previous quizzes might exist somewhere, but they're not a very good representation at all, for which I apologize. The old ones were by a different professor, and I have a very different style of doing our quizzes to that old professor. So even if you find them, they probably won't be very representative of what you're going to see. Like, they're not terrible, they're still good practice, but it's going to be very different style. Mostly multiple choice and short answer. Very short answer. We're not going to get you to write paragraphs. Yep. Yeah, they don't exist. Yeah, you shouldn't be able to find any. They're not on InStock? Okay, so yeah, it's unless you have like an older sibling that did one. But yeah, they won't do you much good. Am I going to give you practice questions? No. Like I said, this is a quiz, right? This is only worth 5%. I want to know what you know, not you're not proving to me that you have internalized all of the techniques of calculus. It's a different environment. So, how well do you know the course? How well do you know what we've covered? Hi. I can't remember. TA's at the back. Do you remember the time of the quiz? 8:30 to 10:30 on the Tuesday of midterm week. We'll send out room details. I believe I need to figure that out in the next day or so. Sorry? AM, I think. AM. Yeah. Yeah, we love our 8:30s, don't we? I'm so tired. All right, so that is our quiz. Let's talk about this week's assignments. We have assignments. They are due the day before your next. Why do I have animations in this slide? They are due the day before our next EGAD session. That is to say, after midterms. There are two of them. One of them is to use your vernier calipers and your incredible freehand skills to go take some field measurements. We have in E5, the Design Center, on these tables, some parts. There's two of them. Pick one, measure it. Measure everything about it. Because after midterms, like the next following assignment, you will have to use your measurements to create a full AutoCAD drawing of this part. Yes, Mun. Oh, yes, thank you. We should probably check the assignment instructions. We might be worth updating. Because yeah, the cable and the screw holding it onto the cable so these don't fall off the table and get kicked away, those aren't part of it. Ignore that part. But yeah, there's two shapes here. Pick your favorite. Measure it up. Measure it up so that future you will be able to do an AutoCAD drawing of this part. Fully, completely, fully dimensioned. Make sure future you is happy with past view and you're not missing anything. So, multiple views, blown up details, whatever you need in your sketchbook with your calipers, measure these parts, or one of these parts. Yes? It's freehand. So, future you should thank, so the question is, does it need to be well proportioned? Future you needs to thank past you. So same grading scheme as always, 5 is good, 4 is okay, 3 is bad but complete, 2 is incredibly bad, we've like just gone completely off the rails and things are badly missing, and 1 is I can vaguely recognize the thing that you handed in as an attempt at this assignment. So we're not going to be evaluating this really strictly because you will suffer for your own mistakes the following week. But we're still going to be like judging the quality of it. Like, did you do a good job? Yeah, no. We're not going to count every dimension because if we see one missing, we'll go, you'll find out. Yes.
But unlike the thing that was due last night, we don't need to.
Yeah, unlike the thing that was due last night, which was specifically an exercise in proportioning, this is about doing a good job using the skills you've developed to do something useful for future you. Yes.
How long will these things be there for?
Until after the due date. So yeah, you've got all of reading week, all of midterm week. If you just want to break and you want to go, I'm sick of calculus, let's go measure some parts. Use it as a break, but it will be there after you're done midterms as well. Yeah. Overdimensioning's fine. But be nice to future you. This is not about good dimensioning. This is about taking all of the measurements you could possibly need. And then the AutoCAD drawing, we're going to evaluate for being an excellent drawing. Our other assignment this week, make an excellent drawing. Remember this shaft design that you did by hand? And you now have feedback on knowing the things you did right and wrong? Now do it in AutoCAD. Perfectly. We will be brutal. Title block, scale, dimensions, line types, line weights, everything. You have the skills to do this right? Yes. Which title block should we use? We've been a little ambiguous. We don't care. But in your title block, you need name, date, scale, title of this drawing. That'll do. Yes. Oh, either you make a circle and you trim out a chunk of it, or you make an arc, or you just do hidden lines. That is another standard. Hidden lines are okay. Yes, the outer diameter is the one that matters. So the inner diameter, you can just offset and make sure it's visibly correct. But the outer one is what we dimension to, and you don't dimension it anyway. It's a hole, you make a hole call out. Like a threaded hole call out. Yeah, the outer side, the outer ring is the one that needs to be the absolute right size. Yeah. No. So the question is, can I release assignments early so you can work ahead during midterm week? Absolutely not. There are a few of you in this class for whom that would benefit, and several more for whom, in my experience, would go, well, AutoCAD is way more fun than studying more algebra, so instead of doing the studying I should do, I will do my AutoCAD assignments that aren't due for 3 weeks. It's also why we don't give you your Lego kits. You get them the week after midterms. We have had problems in the past of people investing way too much time in not passing any of their other courses. Then profs get mad at us because of your poor decisions. So yeah, sorry for those of you who it would do good. We are protecting those who will dive into Lego and AutoCAD instead. Aman? Oh yes. Let me get on my soapbox. Stepping aside from my professor role into my first year tutor and advisor role, allocate your time, give yourself a schedule for reading week and midterm week. Reading week, it's really easy to just do nothing. Most of you are going home. You're going to see your friends. You might get to see your PlayStation for the first time in 2 months.
And after all of the stress, it's really easy to just do nothing for the whole week. That can be very disastrous. Give yourself a plan. That plan should include rest and relaxation. You all need it. But should also include review and practice. Best practice is to do a bit of everything every day. That will give you your best long-term learning. Then once you hit midterm week, you'll just be studying for your next exam. Finish one study for the next one, finish one study for the next one. Still best to intermingle them. Hi, Mun. Oh, are we seeing some people who are investing heavily in freehand when they should maybe have been doing algebra? That's a thing. I'm glad that some of you really like doing the freehands and will spend hours doing the freehands in the AutoCAD. Don't forget to pass your other courses. Schedule your time. If you're not sure how to schedule your time, we have first-year advisors in the first-year office who are happy to help you with study skills and time management. It's a thing that lots of people need a little bit of help with in their first year. All right. Who wants to draw some pretty pictures in our last 15 minutes?
All right. Pull out your sketchbooks and your pencils. So what we are going to draw this week are helices, like drill bits and springs. And they happen to be sine waves. So this will make you better at physics and calculus too, because you'll get better at drawing sine waves.
What we're going to do is to essentially do an orthographic projection of this, as you see it. This whole thing of helices is based on